Hey everyone, my name's Igor and this is the Gravity Engraving channel, all about laser machines and markers. Today we're reviewing the JPT60M7 machine designed for high contrast and vibrant color engraving. It features Q-Pulse control, a licensed controller, and an SG7110 scanner. We still have these machines in stock. If you're interested, I'll leave my contact info in the description. Reach out if you're looking to buy one. Available within Russia. Alright, let's get started. So regarding the equipment, the JPT60M7 features a Sino-Galbo SG7110 scanner, an OPEX f300 lens with a 200x200 work area, an OPEX f420 lens for a 300x300 area, and a generic lens option. The OPEX data lens is a bit more expensive, while the generic one is of course the cheapest option. As for the included accessories, you get the technical documentation for the laser sources, power cables, 2 aluminum stops with mounting bolts, test plates, safety goggles, maintenance tools, and a foot pedal for starting batch engraving. Regarding the technical documentation, I'll show you exactly what to look for, what our starting points are, and what we're aiming for. What should we focus on when reviewing the technical documentation? First, the serial number and source model, YDFLPE60M7MR with a built-in red pilot light. It's a single-mode M7 MOPA series with 60 watts of optical power. The letter E indicates the production region or series. Note that we don't use the E2 versions. The E2 models are stripped-down sources that are popular right now simply because they're cheap. But again, that's not what we're about. People try to save money and end up regretting it. I have no regrets, because we only use the high-quality, original E versions. We also use original controllers from BJCZ. The nominal frequency is 48 kHz with a 200 nanosecond pulse. These are the key settings you should use for deep engraving and general operation on this machine. That means running at 100% power at 48 kHz. 200 nanoseconds is the standard. If you use a lower frequency range, there are certain conditions that I wouldn't recommend messing with, because meeting those conditions is nearly impossible. I'm talking fast because there's a lot to cover in 10 to 15 minutes. Anyway, 200 nanoseconds is nominal, but you can increase the Q-Pulse much higher. You can set the Q-Pulse up to 500 nanoseconds. But don't stray too far from 200, because at those longer Q-Pulse or pulse durations, your source will overheat at least 2.5 times faster than under normal conditions. So keep in mind that if you're working with that kind of Q-Pulse at a lower frequency, you must only run it for short bursts of under a minute and reduce the source power accordingly. Otherwise, the source's power output will degrade much faster than you'd like. I've covered all the other specs on my channel, explaining what each part does for these sources, and in much greater detail. For customers who buy equipment from us, I provide short videos to help with the initial setup and get you started easily. They're about 20 to 30 videos, each between 1 and 3 minutes long. In those, I quickly and clearly explain how to start the machine, install the drivers, and begin working with the equipment. A bit about working with Q-Pulse control. There's a table that specifies the standard frequency range usage relative to the Q-Pulse. So let's say by using this frequency and this Q-Pulse, we get the nominal power output of our equipment. Again, frequency adjustment is allowed within a range, but the Q-Pulse must be set to the same value as our frequency or lower in order. If we use a frequency of 160 or 170 kHz instead of 150, set the Q-Pulse to 30 nanoseconds or less. If we use frequencies of 105 and about 110 kHz, the Q-Pulse is set to 80 or lower. And nominal values at 48 kHz and a 200 nanosecond Q-Pulse, which the table says can go lower but only as allowed. In SCAD 3.0, setting this exact Q-Pulse, well, within these parameter ranges is physically impossible, which is why I think SCAD 3.0 is a somewhat flawed controller in this regard, and consequently, working with the M7 series will be practically impossible. And accordingly, let's not forget about the essential items. This is the logbook for recording parameters and characteristics, 2 copies of the contract that we must send to clients, only original contracts with signatures and stamps along with the equipment, and a flash drive containing SCAD itself, specifically a clean and configured version for working on this equipment. We make a copy for ourselves, but it's only kept for a short time, for 1 year, which can then be provided to our clients. While all the necessary data is being copied to the flash drive, we start our machine, turn the key 90 degrees clockwise, and release the stop button. I usually never press it, but it's an emergency stop button in order to shut down the machine just in case in emergency mode if something happens to your equipment. We're starting the laser radiation source. We usually start the laser radiation source in advance, 5 to 10 minutes before starting work. Launching SCAD 2.0. SCAD 2.0 is a licensed version. Go to File, System Parameter, or System Settings, and in the Language tab, select Russian version 2.1. Restart the program, and you'll end up with a fully Russified menu for working with SCAD. Press Ctrl O and go to the Parameters tab for 60M7. We have a large, quite extensive assortment of different layouts in our database, already prepared and tailored for various equipment. Again, the range of equipment that we sell, and accordingly, we also have these presets. We select the necessary preset based on our tasks and accordingly our lens. In our case, an f300 lens is used. So there's this color engraving test for 300. There's a Russian flag for the f300 lens, and accordingly other specific characteristics. Let's run the color engraving test again. We'll do it on stainless steel and see what else we'll test for our equipment. There are also additional tests here indicated by the size of the working field. Working field 100 by 100, 150 by 150, 174 by 174, and 200 by 200. When working with the machine, don't forget to remove the protective cover. Put in the stainless steel and set the focal distance. All focal distances are marked on the ruler, specifically with special cursors directly on the galvanometric scanner itself. The engraving's done. The engraving was done once again using a standard table, without any special complications or complaints. A matte colored substrate was not used here. With a matte substrate, the color will be more contrasty, more saturated, and much brighter. Moving on to the next tests. And these tables, I'll repeat once more, will be available to our clients and those who purchase. Specifically, the training course for beginners on working with laser machines and markers. So let's wrap up with the final results. Basically, engraving and material removal in both hard and soft modes are acceptable, and the level of detail is also fine. And of course, we have a rich black color here. It also turns out quite well, actually excellent. I've saved all the parameters, color engraving is also possible. Don't forget about the color table. Again, we've handled it with our hands, and since the surface wasn't matted, it's gonna look a bit dull. With a matted surface, the colors come out much brighter and more saturated. There's also a graphite black color here. What else can these machines do? You can do deep engraving on brass, create nameplates, any kind of templates, prints, I don't know, the same cliches, molds, structures, whatever. Making nameplates for boards, souvenirs, knives, weapons is also unique. By the way, it can be done without any problems. Tags with deep removal, engravings with backgrounds, tones, and color engravings are all possible and realistic. Engraving on aluminum, darkening aluminum, and again, not just pure aluminum, but also cast aluminum or alloys with a high metal content. Plus, cutting aluminum on this same machine. But again, I'll repeat, cutting is not the primary function here, it's an additional one. Engraving on stone, plastics, and other materials is also possible and can be performed here. On a machine like this, they make titanium washers just 0.8 millimeters thick. Engraving, color setting, polishing, and more are possible here. If you're interested, I'll put the phone number in the description. Get in touch, write or call. If I can't answer, message me on WhatsApp and I'll reply as soon as I can. The JPT60M7 is a MOPA laser with Q-pulse control, so you can adjust Q-pulse duration and other settings. It can engrave on metal with high power, and again, you can work on large surface areas. You can do color engraving, contrasty, saturated, or black. It works on stone, brass, and other materials. In some cases, you can even cut metals. For those interested, we ran the test on the JPT60M7 machine with an f300 lens and a 200 by 200 working field, contract number 063. Actually, this is a report video about the performance of this machine. The machine is assembled using high-quality components. That is, the Sino-Galvo SG7110, which is a galvanometric scanner, an OPEX f300 lens with a 200 by 200 working field. I'm repeating this many times because some people don't hear us, so I'm repeating it over and over again. The controller from the JCZ company is a licensed one in a metal casing, meaning we only use light software. Version 2.14.16 is suitable for working with SCAD 2.0 as well as with Lightburn programs. Once again, if you're interested, please reach out. For these machines, I'll leave the phone number in the description. The contact number is mainly for, "What's up? If you try to call, I might not be able to pick up. So I either film these videos or I film reports on some other equipment or we're assembling some equipment. All right, guys, good luck to everyone. Peace, prosperity, and bye-bye, everyone.